Let's go ahead and write some binary ionic compounds. First of all, let's do a quick review. We need to be able to find the charges of ions from our periodic table. So here's a little view of our periodic table. The very first column, remember each of these elements has one electron in their outer shell. Well, they want to have 8. So hydrogen's kind of the exception here, so don't worry about it. But they want to have 8. How do they do this? All of these metals lose one electron, which would give them a charge of +1 as an ion. Second column, very similar. They have 2 outer shell electrons. So they lose both of those. That gives them a +2 charge. We won't worry about these transition metals for now. Many of the elements here in this next column have 3. So aluminum's the big one here we want to be aware of. They lose all 3 of those. Now this middle column, we don't do a lot with ions, so I'm not going to worry about it. Nitrogen, nitrogen, phosphorus. These have 5 valence electrons, 5 outer shell electrons. How do they get to 8? Well, they gain 3 electrons, so that makes them -3. Oxygen, sulfur, they have 6, so they need 2 more. They take those from somebody else, that makes them -2. The halogens, very reactive family, they have 7, they're really close, so they get 1, and they have a -1 charge. The noble gases, of course, very stable, their outer shell's already full, they don't need any more electrons. So remember, when we form ionic compounds, we want a neutral overall compound. The opposite charges attract one another and cancel each other out. So sodium, we go find sodium from the periodic table. It's Na. What charge? Well, it has a +1. And usually if it's a 1, we don't need to write it. Oxide, oh, that comes from oxygen. What charge? -2. So when we put these together, hopefully you can see what we would need. Sodium's got 1 positive, oxygen -2, so it would take 2 sodiums. Here's a really quick way, though, I like to show that and teach. If you just circle the charge, don't worry about the sign, but the number, and you could think there's a 1 there, and you just bring it down. I call this the cross and drop method. What does that give us? Na2O, sodium oxide. How about barium sulfide? Barium, Ba, it's in the second column if you go find it. And again, you get more familiar with these. You need to know the column so you know what charge, right? And it's a +2. Sulfur, sulfide. So it's right here under oxygen. Sulfur is a -2 or a 2-. You can write it either way. Notice these have the same but opposite charge. So we only need 1 of each. You could also cross and drop though. And that would give us Ba2S2, and then kind of like fractions, you could reduce and say, oh, I don't actually need 2 of each, so it's just Bas, barium sulfide. How about potassium nitrite? Potassium, we go find it, here it is, K, first column, it's +1. Nitride, that's nitrogen. Notice the ending of these words just ends to ide, so nitrogen, and it's got a -3. Cross and drop, can you see the trend here? So K3N, potassium nitride. Calcium phosphate, calcium phosphide, excuse me. Calcium's in the second column right here next to potassium, so it's a +2. Phosphorus, if we go find it right under nitrogen, has a -3 charge. Can you see what it's going to be? Cross and drop, Ca3P2. Hope that helps. Let's get some practice. Of course, if you have questions, reach out to your instructor.